Okay, it's exam season, you're panicking, you want to know references off the top of your head to show that you're reading the literature, but you can't possibly remember lots of different papers for lots of different questions that come up on lots of different exams. Here's one that covers a few things. Okay, immunotherapy in cancer is likely to come up across a wide range of modules, and this new paper that came out literally last week in Science covers so many different lines of thought. So if you just read this one paper, you can use it to answer lots of different types of questions, really in lots of different types of exams. So one line of thought that you can use it to demonstrate is around cytokine engineering, and you can say that traditional cytokine engineering changes the strength of the signaling, but these trikines can change the type of STAT signaling output. So for example, like whether you get STAT5 or STAT3 being phosphorylated or both at the same time. This can generate new biological programs. That's a phrase you can use. It's easy marks because you can show the direct contrast between qualitative versus quantitative modulation. And it is also one of those papers that nicely links mechanism through to phenotype through to therapeutic rationale. So it ticks a few different boxes for your paper. If you want to get a little bit more specific, you can mention that these trikines assemble three-chain receptor complexes. So that'll help you achieve signaling combinations not seen in natural cytokines. Another point, and again, this can be applied to a number of different topics, is that STAT3 versus STAT5 balance maps quite cleanly onto T-cell fate. That is a phrase you can use. So higher phospho-STAT3, you get stem-like, less exhausted T-cells, but if you have higher STAT5 phosphorylation, you see proliferation, but a risk of exhaustion or differentiation. This is a reusable axis, so you can use this to apply it to like immunotherapy, chronic infection, CAR T-cell, lots of different answers. And remember to mention ratios. So phosphostat3 to phosphostat5 ratios correlate with stemness markers versus proliferation and exhaustion markers. Thirdly, you can say that trikines actually improve therapeutic index. So they do this because their signaling is restricted to cells that express the full receptor combination. So it reduces off-target activity and toxicity. Again, that's a principle that you can apply to so many different topics. A concrete example that you can drop in from this paper is IL-2/21 trikine maintains anti-tumor efficacy but reduces toxicity by limiting NK cell function. This shows that you're thinking about translational implication. So we see that nice bridge that you actually kind of understand the basic signaling, but you also get the clinical limitation really, really nice in an exam. It's also just nice to see that you've been reading a paper that's super recent and super high quality. So drop this one in, look super smart, thank me later.